Hi, how are you? I hope you are doing good. And also, I hope you have enjoyed my previous three lectures that have reached to you through YouTube. And today, I think this is my fourth lecture on biochemical toxicology. We have discussed about free radicals, then we discussed about lipid peroxidation, and then we discussed about the oxidative stress. And now we move to the next topic in this line or in this chain, and that deals with antioxidative mechanisms. And when we talk of antioxidative mechanisms, we talk of enzymatic antioxidants and non-enzymatic antioxidants. But prior to that, there are certain very important molecules that are playing a very important role in detoxification of xenobiotics, in detoxification of drugs. And I would like to discuss today with you one such important molecule to which we call as glutathione, or to be very specific, the reduced glutathione. And in short, in brief, we can call it as GSH. So let me talk to you on this GSH system as such today. I love to work on GSH and I love to talk on GSH because GSH is inevitable. GSH is ubiquitous. Except the archaeobacteria, GSH is present in every living organism, whether it is a prokaryote or whether it is a eukaryote. It is inevitable. Uh, it was discovered maybe 100 years ago by a person, Ray Palihade. His name was Ray Palihade, and the exact date or year is not known, but it was discovered by Ray Palihade, who discovered this molecule. And later on, the Kosovars in 1940s, they said that they said a phrase, and we very fondly remember that phrase, lest I forget the glutathione. That glutathione is such an important molecule that we cannot forget its importance in life. I wrote an article sometimes in 2001 or 2, and the title of that was Inevitable Glutathione. Inevitable Glutathione. And then and now. It was published in Indian Journal of Experimental Biology and it was read by more than 200, 300 people at that very time. I do not know how many have read it now, but it was very important contribution from our laboratory on inevitable glutathione. We became interested in glutathione in maybe in 1985 or so, and we started looking for that what this glutathione is. And when we searched the literature, we found that glutathione is a tripeptide. It contains three amino acids. One is glutamyl, another is cysteine, and another one is glycine. So gamma glutamyl cysteanyl glycine is the full name of this molecule, glutathione. And the precursor of glutathione is two very important amino acids. They are often discussed in many chemical therapeutic experiments. One is methionine and another one is cysteine. These two are the precursor molecules of glutathione. So, this is the brief history of glutathione. How it started, people, we got a very important method of analyzing or estimating glutathione. We still call it as Illmann's reagent. And the people who were working at that very time on detoxification mechanisms, We talked about phase 2 reactions, and at that very time, we talked about methylation, acylation, and also conjugation. And when we talk of conjugation, we talk of glutathione conjugation, or the process of conjugation mediated by this important tripeptide glutathione. So it is called as glutathione conjugation. Glutathione, how glutathione will be responsible for any detoxification mechanism? It will be causing it, or it will be facilitating it through a mechanism that we call as glutathione conjugation. Glutathione conjugation is very simple to understand. It is like this, that there is X plus GSH, or there is metal M plus GSH. You remove G and put M or X in place of G. It becomes a conjugation product. And these conjugation products are the same, those conjugated dyes. These conjugated products are mercaptans, because they take the process of the formation, or they follow the process of the formation of mercapturic acid, and ultimately they are excreted in the urine in the form of mercaptans. This is how the glutathione plays an important role in detoxification. We call it as GSH. Kaplowitz, there was a worker, Kaplowitz, sometimes in 1950s, he published a paper, Synthesis of Glutathione in Liver. I told you glutathione is present in bacteria, glutathione is present in plants. Glutathione, the origin of glutathione is from chloroplast in plants and mitochondria in prokaryotes, in eukaryotes. So these two are the places from where the glutathione comes, from where the glutathione originates. And what is the concentration of glutathione? In in blood, it is having a very low concentration. It is having just a 1 to 2 micromoles, mm, and in the liver it goes up to 12 micromoles. Generally, it is maintained as a 7 to 12 micromoles in the liver, and it is synthesized in the liver. From where it is synthesized? From precursor molecules, methionine and cysteine, and it remains there. 80% of the glutathione system, that is the reduced glutathione, is 80%, and 20% is the oxidized glutathione, that is GSSG. So the cycle continues. Now imagine a situation is there, that there is a poison, that poison enters into the system, poison generates the reactive species, those reactive species enter into the cell, and the cell recognizes them, the conjugation follows with GSH. So when GSH conjugation occurs, the quantity of the GSH in the cell declines. Quantity of the GSH cell declines because GSH is consumed in that conjugation mechanism. To replenish that GSH concentration through oxidative mechanisms, we take the use of GSSG. So that GSH comes from GSSG. In this way, a cycle continues. GSH, GSSG, GSSG, GSH, GSH, GSH कंज्यूम हुआ, GSSG ने उसको रेप्लेनिश कर दिया. इस तरह से एक साइकिल चलती है, जिसको कि हम ग्लूटाथियोन साइकिल भी बोलते हैं. And later on, this glutathione cycle, in sophisticated terms, it becomes the redox mechanism. It becomes the redox biology. It becomes the redox. Later on, people talk of redox medicine. Many people started working on glutathione. I remember when I started working on glutathione, very few papers were coming out at that very time. 100 papers, 200 papers. And can you imagine, just in 10 years it was 2000, and just in another 10 years, maybe now we are getting more than 20,000 papers on glutathione coming out throughout from different laboratories throughout the globe. So much is the interest in this particular, or in this important molecule. GSH. Why so many people are interested in this molecule? Because this molecule protects you from the oxidative abuses. This molecule protects you from oxidative stress. This molecule protects the cell from the reductive stress. And where does this molecule lives? Where does this molecule resides? The main site is the pool, cytoplasmic pool, where it originates from mitochondria. It remains attached sometimes with ER, because ER stress also takes place. I told you in the previous lecture that there is a very close relationship between oxidative and ER stress. I shall be discussing this mechanism sometime later, but today we are to discuss only this mechanism, this molecule. So this molecule remains in the pool. As soon as a foreign material comes, it binds with that. And after binding it, it excretes through the organic anion transport mechanisms, through another multi-drug resistant proteins, MMRPs. Those are the transporters. Through those transporters, it is thrown out. It is not like this that the glutathione generally does not cross the cell membrane. The oxidized glutathione, GSSG, sometimes cross the plasma membrane, comes out of the cell, but GSH very rarely comes out of the cell. It prefers to remain in the cell and function for the cell. Function for the cell means to protect the cell. Now, what happens when the drug enters into the cell and binds with it, and it is taken out and it is changed into mercaptans? How the uh, the transfer of the glutathione to these moieties takes place? It takes place with the help of an enzyme which is we call as glutathione transferase. In phase third reactions, I was discussing you that glutathione transferase is a transport mechanism. Glutathione transferase catalyzes the reaction, and after that catalysis only we get the mercaptans. After that catalysis only we get the water soluble products or less harmful products. So that is with the help of the glutathione transferase. So these are, we call them as glutathione dependent enzymes. How many these enzymes are? These enzymes are glutathione transferase, glutathione reductase, glutathione peroxidase, gamma glutamyl synthase. ये क्या है? Gamma glutamyl synthase is an enzyme which helps in the synthesis of the glutathione in the cell. Gamma glutamyl synthase. So coming back to that glutathione reductase, what does that enzyme does? Whenever GSH is needed by the cell, the GSSG uses this enzyme to produce GSH. So whenever it reduces GSSG and we get GSH. So the GSH reductase helps in the synthesis of GSH. When GSH pool goes down, I told you it is up to 10 millimoles. But in a situation, say for example, it reaches 1 millimole. So the cell needs to replenish it. And how it will be replenished? From where it will come? It will come from the pool. It will come from GSSG. And the enzyme GSSG reductase will help in the catalyzing the reaction, and we will get the supply of GSH for the cell. There is one more enzyme, that is glutathione peroxidase. Glutathione peroxidase works against the peroxide radicals. So what happens is when glutathione neutralizes the reaction, we get the products like H2O2. We get the products like formaldehyde. We get the products like epoxides. So we get the products like this, and they are all, you see, and we get we call them as mercaptans. They are all mercaptans, and they are produced after the mercapturic acid reaction. So who will deal with this dangerous level of hydrogen peroxide? The glutathione peroxide will eat it, and glutathione peroxide level will go down. Always remember, when the activity of the reactive oxygen species or aldehydes is high, the GSH level is low. And when GSH level is low, at the same time, the glutathione peroxidase level is very low, and the level of the glutathione reductase fluctuates. It keeps on working all the time. Oh, cell is not having proper GSH, let me work. Cell has produced sufficient amount of hydrogen peroxide, let it be eaten up by the glutathione peroxidase. And if there is the generation of epoxides, we have got another enzyme which is called as epoxide hydrolase. So the story of glutathione is very interesting, that it is present in all vertebrates, it is present in all invertebrates. Previously, it was difficult to convince the people that glutathione and these glutathione dependent enzymes are present in invertebrates also, or if they are present in lower vertebrates also. I myself published a paper on fish, and it was very difficult for me to convince the members of the editorial board of the journal that look here, in fish also glutathione has a role to play, in plants also glutathione has a role to play, in bacteria also glutathione has a role to play, in all prokaryotes and eukaryotes except the archaeobacteria it is present everywhere, and so are these enzymes. So it's very interesting to understand this glutathione system, and especially the role of the glutathione system as a detoxification mechanism. Sayce, Helmut Sayce, I respect him, the Capus, H. Capus, then the Jacobi, then there are lot many people. So I shall be discussing with you these enzymes again. When I talk of non-enzymatic and enzymatic antioxidants, we will take up each and every enzyme in details. Who discovered, how it was discovered, what is the function of this enzyme. This all is to be taken up separately when we discuss about the enzymatic antioxidants. At present, I am talking to you with a system which you should understand, which is the crux of biochemical toxicology, and that is glutathione system, that is very close to the science of redox mechanisms, the science of oxidative and reductive mechanisms. I suggested long back, maybe in 1991 or 92, that glutathione is not only reductive, glutathione is also playing a very important role as a chelating agent. And that my proposal or my hypothesis was accepted by several people, even including there used to be a person, he published a paper in pharmacology, journal of pharmacology toxicology, and he gave my reference that my laboratory suggest that glutathione works as a chelating agent, not only as a reductive agent. Glutathione, not only as a protective agent, glutathione functions as a chelating agent also. So we keep on working on glutathione, we keep on working on trying to find out the glutathione cycle. It's not advisable to study only the reduced glutathione that has got the moiety of sulfur groups. It is very essential to study the oxidized glutathione also. So whenever we measure reduced glutathione, we measure oxidized glutathione also, because that is the cycle, glutathione cycle we call it. And that glutathione cycle is maintained with the help of glutathione dependent enzymes, glutathione reductase, glutathione peroxidase, and this reaction is catalyzed by glutathione transferase, and whatever the products are formed, we call them as mercaptans. and the process is called as mercapturic acid. Remember it. I can ask you what is mercaptan and what is mercapturic acid, what is GSSG, what is GSH, what is the role of glutathione transferase, what is the role of glutathione peroxidase, from where glutathione comes, how it is synthesized, what are the precursor molecules of glutathione transferase. I think I have given the answers to all these questions, and it will be helpful to you to study this inevitable system that I call as, or we call as, a GSH system or glutathione system. Thank you for watching. Keep on watching. I'll giving you some more information in my new next lecture.